Welcome everyone in the next tutorial of the warping stress analysis. This lecture will mainly talk about the different type of a temperature variation. We will also mainly talk and discuss the two different type of a temperature variation stresses. We will also try to understand the basic concept of the positive and negative temperature gradient as well occur due to the temperature variation. The temperature stresses are developed in rigid pavement due to the variation in slab temperature. We have two different type of temperature stresses. The one is warping stresses, while another one is the frictional stresses. First of all, we will mainly try to understand the basic concept of the warping stresses. Warping stresses are because of the result due to the temperature gradient across the thickness of the slab due to the regular or daily variation in the temperature. Warping stresses occur at the top surface of the slab, which is subjected to the wide range of temperature during the daily traffic cycle load, where the temperature of the bottom of the slab is a contact with subgrade, which usually remains relatively constant. As you can see here, according to this figure, the temperature gradient across the slab thickness causes a differential expansion and contraction during the night and daytime, and we have the temperature like the tension occur at the top at the night time when it's warmer, so the compression occur at the top while tension at the bottom. Okay, so the temperature gradient across the slab thickness, which also causes differential expansion and contraction between the top and bottom of the slab due to the warping stresses, which is basically developed within the slab. In the daytime, as you can see here, the top of the slab expand more as compared to its bottom, and also the slab may assume a shape of a concave upward, which is shown in the another figure as well. Okay, the weight of the slab and load transfer devices will tend to bend it back to its original position, and hence, because of the compressive stresses which occur at the top and tensile stresses at the bottom of the slab. So in the night time, the top surface may contract, and hence the corner and sides of the slab may warp upward, which leave the upgrade. Okay, the till the subgrade of the slab. Okay, as you can see here, the itself time of the slab through which it usually transfer loads through dowel bar or tie bar, is maybe you have idea a little bit about. We usually provide different type of a joints in the rigid pavement. So the basic purpose of the joint is to prevent pavement from the cracking. Okay, so we try to divide the slab into small slab by providing joints in different mats. Okay, which we also call the jointed plain concrete pavement as well. So the purpose of the joint, which ensure that stress is developed due to expansion and contraction of the due to the warping stresses of the slab or within the permissible limit. So joints may be provided in longitudinal as well as in the transverse direction. Joints are also provided for like up to 5 meter, while the longitudinal joint is also provided to prevent the slab and from the longitudinal stripping as well. Okay, we have 4 types of joints which we provide in the rigid pavement. The first one is the expansion joint, second one is the contraction joint, which is basically happening expansion and contraction in the warping stress as well, while the third one is the warping joint, while the fourth one is the construction joint. Here is very important parameter which need to be explained, which is also called the recovering time. So sometime we also believe that the pavement or the rigid surface or the slab are alive, or we also call it that the pavement have a self-healing ability as well. So the raised portion of the slab, which you can see here in the figure, it try to bend it back to its original position. So thus tensile stresses produced at the top and compressive at the bottom of the slab. The second type is fractional stresses. So those stresses which are developed due to the overall change in the slab temperature due to the seasonal variation of temperature. Okay, seasonal. So when a uniform change occur in slab temperature, it will expand or maybe contract. So if the movement of the slab is free, so then more stresses will be developed. But if friction is produced between slab and subgrade, so the movement of the slab will be restrained by the friction. So all the stresses will be developed in the slab. So during expansion or compression, stresses will be developed during like which we call tensile stresses. So this is the basic way how the frictional stresses are actually developed. So we have another type which is also called the moisture induced stresses, which is because of the difference between the top and bottom of the slab moisture content. Okay. The next topic is about the flexural stresses which are occurred due to the warping of the surface heating. As you can see here in that specific figure, so this is the portion which was above the like in the top layer, while this is the one which was exactly below the surface. So that specific portion was open to the temperature variation. As you can see here, we have little bit changes in the top slab surface. So the surface which is kind of a bent, or where you can see some changes with your own naked eyes, was considered h by 2 and h by 2. So h is basically the total height of the thickness of the whole slab. So all those flexural stresses are equal to what? Of equal to basically the three factor. The very first one is equal to the constant stresses. So this whole portion is under the constant stresses because of the dynamic load weighting plus its self structure load. Okay. The second part is called the linear stresses. Linear stresses is happen because of the tire pressure, which is assumed to be equal to the pavement surface in a contact contact with the stresses, while the third part is called residual stresses, which is basically resulting from the environmental factor as well as the thermal expansion or contraction as well. Okay. It could maybe because of the material response as well. Okay. So like so the all those stresses, all those warping stresses which occur due to the surface heating are actually equal to the contact stresses plus linear stresses plus residual stresses. Okay. This is the formula how we can determine the warping stresses occur in the slab. Okay, so H is you can see here sigma W is actually denote the stresses occur because of the warping stresses. So mu is Poisson ratio, while H is a slab thickness which should be provided in the millimeter, while delta T is basically the temperature gradient, which should be equal to the temperature variation divided by the total slab thickness. while delta T is basically the temperature, temperature difference among the top of the slab and bottom of the slab, while alpha is the thermal coefficient, while E is the Young modulus of the concrete. Okay, this is very much important. It actually gave us a little bit idea that how all those stresses actually work. Is you can see here we have three type of a basically stresses occur. Okay, so because of the deformation occur due to the heating of the slab, is you can see here in the very first portion we have all the reduced stresses, so which exactly gave us a kind of a very single peak. But because of the temperature variation and also the bending stresses because of the slab deformation, we have quite unexpected stress pattern. Is you can see here we have a slight increase and then abrupt decrease were counted because of the temperature variation, while in the next one it actually tell us that the total length is basically greater than the length of the critical. So basically L critical means the critical slab length, which is assumed to be rigid support along the slab edges. Okay, uh, in a very short word, in the last figure, because of the warping stresses, because of the changes in the heating pattern, the slab don't have enough time, because that specific middle portion is under contact warping stresses, or sorry, under a continuous warping stresses. Okay, so we have a increased pattern, and then we have the lower temperature time, and then it's again decrease. This is the way how we can determine the negative temperature gradient, which we call concave. Okay, so in the daytime the top surface expand more than its bottom, is you can see here, and then we have the concaved in the upward direction, and then we have concaved in the curling position as well. So this is the formula through which we can determine the deformation of the slab due to the warping stresses, as well as we can also determine the stresses as well. We can also determine the moment of the slab, which try to heal itself. Heal means it comes back to its original position. So this is according to the Westergaard, that all the flexural stresses occur in a concrete because of the dynamic loading. It should withstand against those two type of a different loading parameter. The number one is the traffic load, while the second one is the thermal impact. So the thermal impact actually bring the concave, the upward or downward movement of the slab, while the traffic load actually put pressure from the top, which increase the kind of a bending stresses in the downward direction. But because of the thermal impact, the slab could also move in the upward direction, but because of the traffic load, the slab can only move in the downward direction. This is the formula that how we can determine the maximum allowable bending tensile stresses. To bring this chart, the ultimate purpose is, for example, in the upcoming slide, we will also try to understand the different parameters, okay, such as maximum bending tensile stresses. We will also try to determine the deformation. We will also try to understand the maximum allowable bending tensile stresses as well. Okay, the purpose of the maximum allowable bending tensile stresses is, this is basically the limit beyond which we did not allow the stresses, or in a short word, the slab is basically not designed to withstand against those heavy loads. This is a very typical example. Okay, as you can see here, our main core task is to determine different four parameters. So we have the slab thickness, which is mentioned as 200. We have a Young modulus. We have a Poisson ratio of the slab of the top layer. We have thermal coefficient. We have flexural strength. We have slab length. We have a slab width, and so on. Okay. So what we need to determine, the first task is to determine the maximum bending tensile stresses. The second one is we need to determine the deformation. The third one we need to determine the moment of the slab, while the last one we need to determine that the slab is under the allowable bending tensile stresses or not. Okay. Is you can see here a very clear picture or image is drawn for the solution purpose. Okay, so you can also determine or like write all the given data, and also for our own easiness we also need to write down that what we need to basically determine, such as all those four parameters as well. Okay. As you can see here, the first task is we are trying to determine the maximum bending tensile stresses. So for that we have a formula, sigma w is equal to 1 by mu into h into del t divided by 2 multiplied by alpha and ek. So what is h? H is basically the slab thickness, delta t is a temperature gradient, while alpha is a thermal coefficient, while delta t is basically the changes which occur in the slab due to the temperature variation, while E is the Young modulus of that specific layer. So when we put all those values, so we have a very through a very simple solution. We have a sigma W which is which almost equal to 2.3 Newton per mm square. Okay. As you can see here in the third step, we are trying to determine the deformation which occur due to the slab heating or temperature variation. So for that purpose we have a formula, F is equal to delta T into L into L critical divided by 8 minus 2 into 2.5 into 10 to power minus 6 into L critical power 4 divided by E into H square. Okay. So keep in mind when we are trying to determine the temperature, which was quite clear that the slab should satisfy not only the traffic load but as well as also the temperature variation as well. As you can see here that formula have two part. The first portion is trying to resolve or withstand against those temperature variation issues, while the second part is trying to determine or focus on the dead load plus dynamic load variation. So our first step is to determine the L critical. So what is L critical? This is basically the critical slab length through which we assume that the rigid support along the slab edges. Okay. So the formula for L critical is 167H under root of alpha delta T into E. When we put all those value here, so we have a formula, we have the result of 5488 mm. Okay. So we have a formula for the deformation, which is almost like as you can see all the parameter what we actually needed is already there. Okay. So we have L critical, we have the value of E, we have the value of H square as well. So while putting all those excuse me, while putting all those formula, all those values in the formula, we can determine the deformation value. Okay. So now we are in the third part where we are trying to determine the moment of the slab through which the slab heal itself. Okay. So m delta t, which is equal to 1 by 2 into delta t alpha E h cube divided by 6. So sigma w is basically the maximum bending tensile stresses, which we already determined from the very first stage. Okay. We have the changes in temperature as well. We have the thermal coefficient, we have the value of Young modulus, we have also the total thickness. While putting all those value, so we can determine the moment of the slab as well. So the very last portion through which we are trying to determine the maximum bending tensile stresses, which formula was already mentioned in the previous helping chart. So you can also follow the same way as well. So for while resolving that equation, we can get our maximum bending tensile stresses as well. I hope that you have understand the tutorial. If you have any comment to improve or suggest something, or you can also follow me for the upcoming lectures as well. Thank you very much.